Now let's take a look at this problem. Here it talks about the amount of energy that can be derived from particles varies directly with their mass. Notice here's the word vary, so I'm going to put my equal sign there. And we talk about directly with their mass, indicating that we're going to put K times, I'm going to use M for mass, and I'm going to use E for energy. So the formula we're going to use is E, which is equal to K times M. They will give us the numbers for the E and the M, and for step 1 we're always going to solve for K. So what do we have here? For E we have 8.184 times 10 to the negative 14 equal to 9.1066 times 10 to the 31st power. Now whenever you're multiplying a number by 10, you're dealing with scientific notation. So what I'm going to do, and I forgot my K. Now what I'm going to do is I'm going to get rid of this, because what I want to do is solve for K. So I'm going to divide both sides by 9.1066 times 10 to the negative 31st, and this side also by the same number. And that should be more like that. Now notice, this will cancel out, leaving us with the K. So now I am left with 8.184 times 10 to the negative 14 over 9.1066 times 10 to the 31st power. That's equal to K. Now what we want to do is to simplify this more. Take your calculator and divide these two, and when you do that, you will end up with 0.8987. Now notice here we have the bases that are the same, and when they are the same, we're dividing, we can then combine them. So I have this, the negative 14 plus 31 equal to K. Now what I have now is 0.8987 times 10 to the 17th, and that's equal to K. Now we've done step 1. Now let's do step 2. Now that we know what K is equal to, we're still going to use that same formula, but this time I'm going to solve for E, which is the energy. I know that K is equal to what we have here, 0.8987 times 10 to the 17th times now the mass, which is 0.001. When you take your calculator and you come up with that answer, you'll end up with 0.008987 times 10 to the 17th. Now, whenever you're dealing with scientific notation, you may have only one significant digit in front of the decimal. And we say significant digit, that means a number that is 1 through 9. Notice here, these are all zeros, so what I'm going to have to do is move this decimal point over so that it is behind the 8. When I do that, it's going to take 1, 2, 3, take 4 movements to get to this. Well, you're going to have to account for those 4 movements, and because you're going in this direction, I'm going to subtract 4 from the 10th power, because that's how many moves I have. So when you do that, you'll end up with E, which is equal to 8.987 times, I'll use that times, 10 to the 13th power. Or they may have rounded it off so that you end up with 8.99 times 10 to the 13th power. And then this is your final answer.